Okay, so we're looking at page 3 of the exam. I'll just zoom out here so you guys can see what it is. So page 3 of exam 3 for spring 2018. And you can see it's asking us to draw the complete mechanisms for the following, making sure that we show all arrows indicating the movement of electrons, right? So basically it's just saying, draw me the mechanism for everything that's going on here. So we got 3 reactions, 3 different reactions in each case. Here at the top, we've got our halogenation reaction. Whoops, didn't write that quite clear enough. Halogenation, right? That's our halogenation, right? So we're going through our triangle intermediate, right? Our triangle intermediate there where we have a halogen in the middle, right? So we're bromonium or iodonium or fluoronium, whatever, chloronium intermediate. So we have that. This is anti-addition, right? Anti-addition, right? And if we are, or if it does make a difference, it will form a racemic mixture at the end, right? So we've got all these different kind of bullet points for what's going on here. But now you'll notice something, all right? So we don't have the typical stuff of Br2, right? We've typically used Br2 or Cl2. Here we've got Bri. Now, how does this reaction start? Now, remember, in all of the reactions that we're dealing with in chapter 6, the double bond is sending its electrons out to hit something positive, right? So the alkene, right, the alkene is nucleophilic, right? Right, it's a nucleophile, right? The alkene is a nucleophile, and the halogen, right, the halogen is going to be the electrophile. Okay. So in all of the stuff in chapter 6, the alkene is acting as a nucleophile. It is looking for something positive, right? So it is looking for the positive. Okay? It is looking for the positive. Now, if the alkene is looking for something positive, we better make it hit the positive first. So we look at our compound here, right? We've got Br and we've got I. Which one's positive? Well, that's just a simple matter of looking at electronegativity, right? Bromine's more electronegative than iodine is, right? So we've got partial positive here, which means partial negative there, right? So in our case, this is going to swing out, hit that bromine. If you make a bond, you break a bond, right? And then the halogen's also going to send back a lone pair. Whoops. I don't know why my computer did that. Sorry, let me redraw. Let me draw this set of arrows here. There. Okay, right? So we're going to hit the positive iodine, right? We're going to hit the partial positive. So let's take a look at what happens after that first step. So we will end up generating this guy here, right? We end up forming that 3-membered ring intermediate. And remember, we're talking about the sumo mechanism here, or what I call the sumo mechanism. So that iodine is pulling one of its bonds up and leaving behind a partial positive, right? And we leave behind the partial positive on the most stable carbon. In this case, they're of equal stability, right? They're of equal stability in this case, so it doesn't matter which is the next one that we hit. But remember, the partial positive is actually sitting on one of these 2 carbons, either that guy or that guy right there, but they're of equal stability in this instance, right? So we need to make an informed decision about which of those carbons we need to hit, but in this case, both of them are equal, okay? So since they are both equal, that means the positive is as stable as it's going to get, right? If we don't have to worry anything, there's no carbocations or no rearrangements, anything. So we just need to make sure our incoming halogen here, the bromine with the minus charge, is going to hit the most stable plus. So it'll come in, hit that bond there, and pop that out there. Okay? And so our answer in this case is right, either this guy, we could say, or you could have drawn it. Right? Either way would be just fine for you to draw that. Okay? So there you go. Either one of those is going to is going to be an answer. But the key part is right here, right? Let me get this in, right? Understanding this, understanding how chapter 6 works, and making sure you hit that iodine. All right, we'll pick this up for the next reaction in the next video here.